So this is the video on Matter Lesson 4 Textbook Pages Part 2. And this is going to talk specifically about how pressure and volume are related to each other with a gas. So when you push on an object, you're applying pressure, and how much pressure you're applying depends on the force with which you apply it. So in the future, you're going to have to remember that pressure equals force divided by area. We're going to be working with that equation in the future. But the pressure that a gas applies is greater if its particles collide with a surface more often. And we'll talk a little bit about that here in a minute. The air that surrounds you is constantly applying pressure to you. This pressure, called atmospheric pressure, can affect how easily a liquid changes to a gas. Think about boiling water, like if you're going to make pasta, okay? When the pressure inside the liquid is equal to the atmospheric pressure or the air pressure, the liquid is going to boil. And that's especially important when we're talking about how high up in the mountains you are. So the more pressure you have, the higher the temperature is that's required for it to change a liquid to a gas. So more pressure means higher temperature, okay? So that before something will boil and turn to a gas. If you have less pressure, like up in the mountains, it lowers the boiling point. So moving on to slide number 2. We're talking about the relationship between temperature and volume. The French scientist Jacques Charles examined the relationship between the temperature and volume of a gas. And he's the one that came up with, of course, Charles's law. Charles discovered that when the temperature of a gas at a constant pressure is increased, the volume increases. He also discovered that when the temperature of a gas at constant pressure is decreased, its volume decreases. This principle is called Charles' law. So we're going to take a look at a picture that shows Charles' law in action. If you want to go ahead and scroll down to the bottom of your page. We've got the cooling and warming of a balloon. So the volume of a gas-filled balloon changes as the temperature changes. Below each image, shade the arrows to indicate whether temperature and volume increase or decrease at each step. So we start with a gas-filled balloon at room temperature, which is about 20 degrees Celsius. And then we put the balloon into liquid nitrogen, which takes it all the way down to negative 196 Celsius. So that's quite a decrease in temperature. So we're decreasing the temperature, and it wants to know what's going to happen to the volume. So I'm going to go ahead and actually, let's go ahead and circle the correct answers. So temperature is decreasing. And of course, we're going to need to make that transparent. And if you decrease the temperature, what's going to happen to the volume? Well, the volume is also going to decrease. So we put it in this really cold nitrogen here, and then we move over and we remove it from the liquid nitrogen. It's going back to room temperature. So the temperature is going up. So what's going to happen? It kind of deflated here, and now is the volume going up or down? Well, as the temperature goes up, the volume is also going to go up. So we take it from room temperature, and it's starting to get to room temperature, and now it's all the way unfrozen here, room temperature. So again, the temperature is increasing and the volume is increasing. Okay, slide number 3. So now we're going to talk about the relationship between pressure and volume. And this is when we start talking about Boyle's law. In the 1600s, the scientist Robert Boyle carried out experiments to try to improve air pumps. He measured the volumes of gases at different pressures. Boyle's experiment showed that gas volume and pressure were related. When the pressure of a gas at constant temperature is increased, the volume of the gas decreases. When the pressure is decreased, the volume increases. So basically what Boyle's law is saying is that the volume of a gas, when that is changed, when the volume changes, the pressure will change in the opposite way. So, for example, as the handle of a bike pump is pressed, it pushes the particles down into the cylinder, like the air particles. The volume in the cylinder is becoming smaller, and the particles leave through the tube. So when we're looking at that real life example off to the side here, pumping a bike pump causes an increase in gas pressure and a decrease in gas volume. So when you push the handle and you're actually pumping the air, you're increasing the pressure in the tube and you're decreasing the volume, which is the amount of space that the gas has to take up. So we're going to go down to the bottom of this page and answer this question. Draw 2 diagrams to show the air particles in a bike pump before and after the handle is pushed down. Well, I'm not going to force you to draw a diagram, but we're just going to kind of describe what it might look like. So what is the air in the pump before the handle is pushed? What do the gas particles look like? How packed are they? Well, the gas particles are loosely packed. This is before you push the handle. Now, what are the gas particles going to look like after the air in the pump after the handle is pushed? The gas particles are more tightly packed, and that's what makes them want to exit. All right, looking at slide number 4, this is our review slide. These look like excellent test questions. Okay, question number 1. What relationship does Charles' law explain? Well, it's the relationship between temperature and volume. That's the main thing that it's explaining. And it says, as one increases, the other increases. So Charles' law explains the relationship between temperature and volume, and as one increases, the other increases. So if the gas pressure in a ball is low, how will it affect the physical properties of the ball? Well, the ball will deflate and not bounce as well as it did. When the temperature of a gas increases and the volume is fixed means it's not going to change. Volume is not going to change. So temperature increases, volume does not change. What happens to the gas pressure? Well, pressure increases because the particles are more energetic when temperature increases, so they exert more force on the container's walls. So one more time. What happens if you increase the temperature, leave the volume the same? What happens to pressure? Pressure increases because the particles are more energetic when temperature increases, right? The particles move around faster, so they're going to bounce off the walls of the container more, and that's going to increase the pressure. Okay, back up to the top on the right-hand side. How do particles of gas move when there is high temperature and high pressure? And we kind of talked about in the last question how the high temperature affects them. They're going to move quickly and bounce off the walls with a lot of force. So anytime you increase pressure or temperature, you're definitely increasing the movement of the particles. Number 5, environmental scientists collect air samples so they can test the quality of the air. They start with rigid metal containers that are completely empty, which means the air has been pumped out of them. What happens to the pressure inside the container and the volume of the container as air enters it? Well, what's going to happen is the pressure increases as the gas enters, as the air enters, okay? And then the volume stays the same because the container is metal. And that means a metal container doesn't expand easily. It's not like when we did the experiment in class and we had a plastic baggie and the gas particles were able to puff out the bag. A metal container is not going to puff out. All right, final question. You learned about the relationships between the temperature, pressure, and volume of a gas. You also modeled how the gas particles behave in different situations. Using the relationships you've learned about between temperature, pressure, and volume, what are 2 ways you could increase the gas pressure of a system? So 2 ways to increase pressure. Well, one of them is to increase the temperature, right? And the other way is to decrease the volume, which means the size of the container, basically. The amount of space that the particles have to bounce around in. If you decrease the amount of space they have to bounce around in, you're definitely increasing pressure.